I can't believe I took this job as a lumberjack. I mean, I have to pay the bills somehow, and this seems to be the best way to go about it. Alright, but I did find this pretty good looking tree here, so I'm just gonna take my axe and see if we can make some wood out of this. So if I just go up here and slash about, then... Oh yeah! Alright, we got a piece of wood. Damn, this is a pretty big piece of wood too. I hope I get paid big for this one. Alright, so do I just take this and... Oh my god. Oh my god, this wood is so heavy. Alright, I better be getting paid big for this one. Alright, I just need to move this to the Home Depot store so we can go ahead and sell this. Okay, come on. Let's just move it to the store. The store is
only a couple steps away. Okay, this wood is so heavy, as a matter of fact, that it's literally defying gravity by floating around in place. Alright, but if we just keep going, then I think we should be pretty good. Let's just, alright, bring it to the store. Come on, bring it in, bring it in, bring it in. Alright.
We're bringing it in pretty good. Oh, yo! It's just full. Okay. It's just flinging itself inside. That's insane. This is such a magical piece of wood, let me tell you, bro. Okay, if we just bring this over here.
The cash register is right over there. If we just move it over
here. Okay, alright, we got the wood on the counter. There we go. Alright, Mr. Lumberjack, I want to take this piece of wood and I want to get some money out of it. So what do you have to offer? Wait. That log is too big. I'm not taking that. Wait, what do you mean this log is too big? Bro, like, if you want me to make it shorter, I could just take my axe and cut it for you. Bro, what kind of lumberjack doesn't take a log that's too big? That makes no sense. Bro, you are a very strange lumberjack. You know that? If you don't get out of my store, you'll become timber. Yo, what is this slander, bro? Like, okay, I thought you were a very weird lumberjack, but you're also a very slanderish one too. Bro, okay, you know what? I am not taking this mistreatment. If you want to mistreat your lumberjacks like that, then you are not looking at the right lumberjack for the job. I am sorry, Mr. Lumberjack. Okay, and you know what? As a matter of fact, I'm just gonna take my axe. I'm just gonna walk out of the store and pretend that I didn't even work here in the first place. I think what best suited me is becoming a YouTuber rather than a lumberjack. So I'm just gonna walk out of here and pretend I've never seen you. So I will never see you again, Mr. Lumberjack. I'm gonna walk out of here. Yo, he actually took it for real, bro. He turned me into lumber. Damn. Alright, well, I will take that as a lesson to never become a lumberjack ever again, because I hate this job. Alright, let's think about this for a minute. In this episode, we're going to be talking about drag detectors, which is actually something I'm very much looking forward to talking about because a lot of the episodes in the advanced scripting tutorial guide up until this point have actually been using these drag detectors through these conceptual examples that I've been showing you throughout a lot of the episodes. Like, I think this one is for the data stores video, the one over here is for the run service video, and I believe the one over there is for the teleport service video. So a drag detector basically allows you to take any 3D object and basically drag it around inside of the workspace. So I take this part right here and then I can drag it in the game, and it applies physics to be able to do some stupid stuff inside of the game like this. Now, the purpose for this episode is to show you how to implement these, how to configure these drag detectors so that they don't do stupid stuff like this, where it can go into the void like it's no tomorrow, and also implement our own custom drag detectors if we have time for it in the end. But that's going to be the goal for this episode, and I'm going to be very much so looking forward to teaching this, and I'm very excited for it. So I hope you stick around all the way through till the end, and with that being said, let's now go ahead and go straight into implementing. Now that we understand it, let's implement drag detectors inside Roblox Studio, and the easiest way we can do that is just by simply adding a drag detector object and putting it inside of a 3D object in the workspace. So here's what we're going to do. I'm going to go to model, and we're going to hit part just like this. And on the right side in the Explorer, we're going to hit the plus sign and we're going to search up a drag detector like this. And now we have a drag detector object inside of this part right here. So if we go into the game and hit play, then we should be able to try this out for ourselves, where we're able to drag this part inside of the workspace. So if I hover over my mouse, then we can see that it is draggable. So if I hold down the left mouse button and then drag it alongside the workspace, it's using gravity to create this sort of motion that is trying to make the part go towards the direction that our mouse is trying to go into. And this is how we're able to create a very basic drag detector and make a part draggable. But obviously, with the default settings that this drag detector has, it can do a lot of stupid things and create results that we don't want. So we need to be able to know how to configure drag detectors and how we can potentially create scripts to make these drag detectors useful. And so that's what we're going to be doing inside of this episode. The first feature I want to show with this drag detector is the way it responds to motion. And basically what I'm referring to is how it uses physics or constraint forces to be able to drag this part to its desired location or orientation with wherever the mouse is located inside of the workspace while I'm dragging it. So as you can see here, it's using physics to be able to move this part to where it needs to go. And this is what's called a response style. And this response style is called physical because it's using in-game physics to be able to move this part to where it needs to be. But there's actually another response style called geometric, which I'm going to show you right about now. So I'm just going to hit stop. And if we go into our drag detector and we scroll down, then there should be a property called response style. And by default, it's physical. So this is what's using physics to be able to move the part to where it needs to go. But if we hit this drop down, there's two more options called custom and geometric. And one thing to note about geometric is that it doesn't involve physics to try and get to the position that the drag detector is trying to make it go to, if that makes sense. So if I were to set this to geometric and if I were to show you this in game, so by hitting play, then if I drag this part, then there's no physics involved when it comes to making the part go to where it needs to go. It's kind of just, it's happening simultaneously. And that's kind of the difference between geometric and physical, and I hope that this part has been making sense to you so far. There's another quick thing to note about the drag detector's response style, and that is determining if the object that this drag detector is part of is anchored or not. And the reason this matters is because an anchored part by default does not get affected by physics or gravity. So if there is any physical elements that are involved in this drag detector, it's not going to work for an anchored part for that reason. And I'm going to show you this. So if we were to go back to physical response style, and if I was to select the part that this drag detector is a part of, and I select the anchored property, and now I go to test and hit play, then this should basically be the same as a geometric response style in disguise, even though we said this should be a physical response style. So that's something I wanted to note here, that if you're working with a response style, you have to make sure that your part is either anchored or not anchored based on your specific needs for that. And if I were to show you the other case scenarios here, if let's say we had a geometric unanchored part, so a geometric unanchored part will basically make the part unanchored by default, but then once we're dragging the part, it's actually going to anchor the part while we're dragging it, but then once we let go, it's not going to be anchored anymore. So if I were to demonstrate this to you, let's change the shape of this part to, let's say, a ball like this, and I'm also going to make it a little bit bigger as well. So if I hit play, and if I were to roll this around, then it's going to be unanchored. But then if I use the drag detector, it's going to anchor the part. But then once I let go, it's going to go and roll off into the distance again, because that's what happens when you use a geometric response time with an unanchored part. But with an anchored part, obviously, it's not going to roll around at all. And so that's something I wanted to add there for response style. And I hope that this analogy or this explanation has helped you so far to understand it. So now let's move on to the next part. Another important property we need to know here is the drag style. And basically what this does is it determines how we want to drag this part that's inside of the game. And there's a lot of options here to tell you what kind of style you want to have for your dragging. And I'm going to go over some of the important ones here, but let's try and break this down conceptually. So if let's say I had this part and I wanted to move it alongside the x-axis, which is in this direction, or if I wanted to move it alongside the z-axis, which is in this direction, or if I wanted to drag it inside of the y direction, which is up and down, or if I even want to add a rotational element to this as well, then we can do this by determining the drag style of where we want the part to be draggable towards, basically. So that's what we can do here with this drag style. And the first one I'm going to show you is called TranslateLine. And basically this drag style gives a one-dimensional motion alongside the drag detector's axis. Now, I'm going to show you a little bit later how we can configure this direction in a little bit, but by default, the one-dimensional axis is in the Y direction. So if we were to use TranslateLine, then this is going to go up and down like this inside the Y axis. So if I were to just quickly change the response style back to physical, and we need to make sure that our part is not anchored. Okay, it's not anchored. So if we now hit play, then I'm going to show you what TranslateLine looks like. So it's going to only go up and down inside of the Y axis because we specified TranslateLine to be a one-dimensional motion alongside the drag detector's axis, which is the Y axis. So now if we hit stop, I'm going to show you the second drag style, which if we go down here, it's called TranslatePlane, which is basically a two-dimensional motion dragging style that goes along the axes that are perpendicular to the drag detector's axis. So basically what I mean here is the drag detector's axis is in the Y direction by default. So that means the translate plane axes are going to be the ones that are going to be the opposite of the Y axis. So it's going to be in the X axis and it's going to be in the Z axis, not the Y one. So if I were to go into the game, I can show you this just by testing it. So translate plane is going to allow me to drag it in the X axis, and it's also going to allow me to drag it in the Z axis, just not in the Y axis, because that's what the axis for this drag detector currently is. I hope this part is making sense so far. Once again, I will show you how we can configure the drag direction just a little bit, but I hope so far this analogy has been helping you understand these different drag styles. So if I were to now hit stop and go to this drag detector, there are some other ones that are pretty useful, like rotate axis. This is what allows you to have a rotational element to dragging your drag detector around just like this. So it's not going to move, but instead it's just going to rotate in place. So I think that's another useful one. And then one more that I'm going to show you is TranslateViewPlane, which basically takes the part and it drags it alongside the player's screen. So if I were to drag this alongside here, then it's basically going to follow where the view frame of the camera is inside of the game. And so that is basically what TranslateViewPlane does. So if I was, let's say in first person, then it's just going to drag alongside wherever the camera or the view frame is. And so that is basically something that would be pretty useful to have for this kind of drag style. So those are some of the drag styles I wanted to go over here. But before I go over some of the other ones, there is something else we need to know about first. So there are other drag styles here called TranslateLine or Plane, or TranslatePlane or Line. And you might be thinking, what are these drag styles? Well, I can't exactly explain these drag styles unless we understand another concept when it comes to drag detectors. And that is called mode switching down here. Now, basically what mode switching is it allows the player to hold down a certain key to have this sort of modifier input to be able to change the drag style midway while they're dragging a specific part. So basically for PC, we have to press the left control key to be able to switch our drag style midway while we are dragging a certain part. So with these certain drag styles here, with translate line or plane or translate plane or line, if we were to, let's say, select translate plane or line, basically what this is saying is for our primary drag style, it's going to be translate plane that allows us to go on the X and Z direction. But if we were to hold down this modifier input, then it's going to switch the drag style to our secondary drag style, which is translate line. And that is basically what this is trying to say here. So if I were to hit play, I can show you what this looks like in game. So our primary drag style is translate plane, so it's going to go in the X and Z direction. But if now, let's say I held down the modifier input key, which is left control like so, and then I drag it, then it's going to go up and down because it switched the drag style to go to our secondary drag style instead of our first one. And then if I let go, then it's just going to go back and switch to the primary drag style. So that is something I wanted you to know about. And it basically works the same way with translate line or plane. It starts with translate line first, but then once you press down the modifier input, then it's going to switch to translate plane. And I hope that this has made sense to you. So for this next part, we're going to change the physics of a drag detector. And so before we do that, what we're going to do is go to model, and we're actually going to create a new part. So let's hit the drop down here and let's insert a sphere like this. And what we're also going to do is create a new drag detector and put it inside of this part. So I'm going to hit the plus sign and I'm going to insert a drag detector just like this. And so basically what we're going to change here is, if we scroll down here, the physics response category with all these properties that are associated with it. And so if you remember what I mentioned earlier in this episode, the response style with physical is basically what allows physics to be incorporated with the dragging of this drag style. And so it's determined through these properties down here with applies at center of mass, MaxForce, MaxTorque, and responsiveness. Now you might be confused with what all these properties mean, so I'm going to try and explain each one of them to the best of my knowledge. But basically MaxForce determines how much force we want to apply to this part to be able to reach its goal. And this is the maximum that we're going to give it. So if it's anything that's after this number, then it's basically going to be too fast and we don't want it to exceed the max force. But this is actually a very, very large number, and that's actually the reason why it can go off into the void so easily because of it. So what we can do is actually decrease this max force from 10 million to, let's say, 10,000 instead. And so if we go hit test and hit play, then what we should see is if we drag this part around, then it's not going to go off into the void as it was able to before. It's kind of taking its time just a little bit. But if we want to really see the change, then we can actually decrease this even further to, let's say, 1,000. Then it's going to make it even slower because we're not going to be applying a super big max force to be able to reach the goal that we're trying to make it reach towards. So that is what max force basically does. It limits how much force we can apply at any given time for it to reach its goal. And that's basically what it is. So the next property is MaxTorque, which is basically the rotational counterpart to max force. So max force deals with how much force is either being pushed or pulled, but this basically determines the rotational aspect of it, which is how fast or how slow a part gets rotated around, like so. And max torque is basically how much of it do we want to maximize before it reaches a certain point where we don't want it to go even faster than it should. So that is basically what max torque is. And responsiveness is how fast do we want this part to respond to this new location that we're trying to make it go to. So a good way to think about this is the higher the number of responsiveness, the more responsive it is, you know, like how it's like quicker to reach the goal that it needs to reach towards. So if we were to make the max force, let's say 10,000, and we were to change the responsiveness to 100, so it's rapidly more responsive than it was before, then it's going to reach the goal a lot faster, as you can see here. It's basically almost instantaneously going to the direction or location of where my mouse is going. And that's basically what responsiveness does. It's how fast do we want this part to be able to reach its goal without having to exceed the max torque or max force that we specified this part to be. And I hope that some of these properties have been making sense to you. And it honestly just comes down to experimentation to see which one works best for you. But this is a little small introduction to some of the properties. But there is one more property here called apply at center of mass. And basically what this does is, do we want to have the force or the focal point of the physics be involved with the center of the part that we're trying to change, or is it going to be where our mouse is located when we're dragging it? So if I were to set this property to be true, and if I were to go into the game, then I can show you what this looks like visually. So if I were to, let's say, hold the part on the left side here, then it's going to move the part to the center of where my mouse is located. So if I let go and then try this again on the right side, then it's going to move the center of mass to where my mouse is located. Now, if I were to disable apply at center of mass again, then it's going to make the center of mass be wherever my mouse is currently. Now, there's one thing you may or may not have noticed, but if we, let's say, change the response style to geometric, then the category for physical response is gone, obviously, because if we're working with a geometric response style, then we're not applying physics to this part. So that's why this category will only show if we have a response style of physical. So that's one thing I wanted to add before we move on to the next part of this episode. And I hope that you found these properties to be useful. So I mentioned earlier in this episode, we can change the drag direction of a drag detector for a part. And basically what I'm referring to is By default, if we remember, the axis, so if we go down here inside the drag directions category, there's this property called axis. And by default, the axis for this drag detector is in the y axis. So when we started with TranslateLine as our drag style, it's giving us a one-dimensional motion along the axis of this drag detector, which is in the y direction. But we can actually change this drag direction to be something that's not in the y axis, but instead, let's say in the x axis or the z axis. So if I were to change the y axis to 0, and if I were to change the, let's say, x axis to 1, so if we hit enter just like this, then what we should see is if we go into the game and hit play, then we should be able to drag our part alongside the x-axis for our TranslateLine dragging style, since it gives us a one-dimensional motion alongside the axis. But it's no longer a part of the y-axis dimension because we changed it. So we can do the same thing with, let's say, z. So if we were to change x back to 0 and then we were to change z to 1, then we're going to hit play and then it's only going to go alongside the z axis just like this and nowhere else. And we can do some pretty interesting stuff here with, let's say, if we were to change the drag style to TranslateLine or plane. If you remember with TranslatePlane, it's the two axes that are perpendicular to the axis. So in this case, our axis is now z. So the axes that are perpendicular to it are x and y for TranslatePlane. So if we were to go and hit play, then it's going to start in the z axis for TranslateLine. But then if we hold down our input modifier, which is left control, then it's going to switch to TranslatePlane, which is the y direction and also the x direction. So it's going to go something like this. And it honestly requires a bunch of experimentation to try and figure out what works best for you when it comes to changing the drag direction. And I want you to keep note of this if you do decide to change the drag direction of a drag detector. It depends on what your needs are, so this honestly requires some experimentation, but I hope that you found this part to be pretty informative so far. Now, there's another thing you may have noticed, and that is whenever we're changing our axis, it's also changing a bunch of these properties down here. But I think an important one to know is the orientation here. So this is another vector3 value, which gives us an x, y, and z value that basically determines if we were to have a rotational drag style. So if we were to change this to rotate axis, this is the direction that this part is going to go if we decide to rotate it. And the way we can really see this is if we were to change the response style to geometric, because if we were to use physical, then we won't be able to see the changes properly because it's being affected by the physical constraints. So if we were to drag this, then it's going to drag like this, which we specified the orientation to be. But if we were to change the axis to y, so if I were to make z 0 and then y to 1, then it's going to change the orientation again, and this is going to have a different rotational direction for this part, just like this. And so Roblox will automatically configure the orientation or the axis if you change either one of those two. And that's another thing I want you to consider when it comes to those sorts of things. And so I hope you found this part to be helpful. For this next part, I'm going to be introducing movement limits, which basically allows us to have a certain limit of how far we can drag something out before it reaches a certain point. So I created this little drawer example here where we basically drag this middle part outward like this, and then once we reach a certain point, then it's not going to be able to be draggable past this certain point right here, but instead we could just drag it back inside like this, and it can't go outside this way as well. So this is the only space that we can allow movement to happen with this drag detector. And so we're essentially going to be recreating this drawer system right here. So I'm now going to hit stop so we can go ahead and recreate the system. All right, so what I'm going to do is go to model, we're going to go down to part, and we're going to insert a block like this. And I'm just going to scale the part just like this. And I'm also going to change the color to, let's say, this reddish brown color. And what I'm also going to do is duplicate this part to make it go up like this. And I'm also going to duplicate it one more time just like this. And I'm actually going to take all these parts and I'm going to right click and I'm going to group as a model like this. And I'm just going to call this drawer like that. And so now what we're going to do is if we open up this, there's going to be the middle part, which should be this one right here. So I'm going to call this one drawer. And I'm also going to change the color of this drawer to, let's say, black, just to differentiate it. And what I'm also going to do is specify this top right here as well. And this is going to be important later, and I'll show you why. So what we're going to do for the drawer is hit the plus sign. We're going to insert a drag detector like this. And there's going to be a few important things we need to do first. So one thing is for our parts that are not the drawer, we're going to go down and we're going to anchor them because we're not going to make them draggable. And then for this drawer, what we're going to do is for this drag detector, we're going to make the response style geometric. And we're also going to make the drag style TranslateLine because we only want it to go in one direction here. So that is basically what we have going on so far. And what we also need to do is change the axis of the drag direction because by default, it's in the Y direction. So if we left it as is, then it's only going to be able to go up and down, but we want it to go in the X direction like this. So we are going to essentially go to the drag detector. We're going to change the axis to have 1 as the X axis and then 0 as the Y axis, just like this. And so basically that is essentially what we have going on so far. So if we hit play here, then we should basically be able to drag this alongside the X direction. But you may have noticed there is no limit to how far we can drag this thing. And this is basically where dragging limitations come in. And that's what we're going to be adding here. So if we hit stop, then there's this section here called drag limits. And there's 2 properties that's going to be important for us here. The first one is max drag translation, and then this one is min drag translation. So with min and max, basically with these coordinates, how far do we want to be able to drag this part in a certain direction, which is the max, and minimum is how far do we want to be able to drag this in the opposite direction. Now, here's one thing you have to be very careful about here. So if we're going in the X direction, it goes incrementally this way, so it's going to increase the number ever so slightly. If you notice the positional value on the right side here, it's increasing in this direction. But what we want is for this to go in the opposite direction here. As you can see, the position is going further down the list. So instead of using max drag translation, we're actually going to use min drag translation because this is how far we can go in the opposite direction. I hope that part is making sense. So basically what we're going to do here is for the min drag translation, we're going to set this to 5 in the X direction. And we're not even going to change anything in the max drag translation because we're not concerned about what's happening over here in this direction. But instead, if we have the max translation to 0, then we can't go anywhere past this point here. So if we now hit play, then basically what we should see is that we can drag, oh, hold on, I messed something up here. Okay, so there's a little typo here. This should be -5 for the minimum translation and not 5 because we're going to be going in the opposite direction. And that's what's going to be changed with the X direction is that it's going to go down further this way. So if we now drag it all the way back here, then there should be a limit to how far we can go back. And obviously the constraint for going on the right side is nothing. It's just going to be at 0. So this is all we can do for this dragging, which is exactly what we want. But unfortunately, we're not done here, and I will show you why. So there's something in the documentation where they mention how dragging limits is not the same thing as constraints. So basically what I'm referring to here is if we drag this, this is how far we can drag this part within a specific drag. But if I let go and then I drag it again, then, oh, you see what happened there. It's now dragging past where it needs to go, because once my drag is done, then it basically resets the maximum or minimum limit that I had with this drag detector. So when you're in a situation like this, how would you exactly fix this? Well, there is most certainly one way we can fix this, and this is with the use of a reference instance. So I'm going to show you what this is right now. So in order to fix a problem like this, we need to have what's called a reference instance, which is basically an instance that this drag detector is applied to that gives the reference frame that we are going to use to determine if our drag has exceeded this reference position or frame or whatever it is that we're trying to use here. And the reason this is important is because let's say we were to drag this part alongside here, then the reference is still inside of the middle of this part that's right over here with this drag detector. So the only reference that it has is the center of this part. So because the reference is here, we can go -5 studs back down this way, but the position keeps changing. So what we need is a reference that stays in place with this drawer so that it actually doesn't exceed that position. And so I hope once you understand it this way, then you can probably see the importance of having a reference instance for this. But you might ask, what kind of reference instance are we going to have for this drag detector? Well, we can most certainly use something that pertains to this drawer, like this top part that I said was going to be important later, because this gives us a reference frame for where the drawer is located. So basically the way we're able to do this is if we take the drag detector, there's this property called reference instance. So if we select this, then we can select the instance that we want this reference to be a part of. So what I'm going to do is select the top part here. So now, once we're able to do this, then this basically gives us a reference point of where we want this part to be able to move far away from, but not too far away from this reference point. So that is the only thing we need to do here. So now if we hit play, then what we should see is if we drag this part alongside here, then we can't drag this further along because it's not going to go past the reference frame point of this top part here. It's not going to go past it. And also I noticed that this is glitching out a little bit, and that's probably because it's a good practice to make these parts anchored when you're doing a reference style here. So that is basically how we create a drawer system using these drag detectors. Now, if I were to rotate this part alongside this direction, then it's not going to affect the axis whatsoever. And we're still able to make a drawer system work just like this. And I hope from my explanation and also from everything we've learned up until this point that you were able to get a good understanding of how these drag detectors work. Now, there are scripting events we can use to detect certain things, like did the player start dragging this part, or is the player still dragging this part, or did they stop dragging this part? We can do that through a script. So what I'm going to do is go to the drawer and we're gonna hit the plus sign and we're gonna insert a script like this. So I'm going to make reference to the drag detector by saying local drag detector equals script.parent.dragDetector like this. And what I'm going to do here is say drag detector.dragStart connect function, open and close parentheses, enter. And there are a lot of parameters that does get passed here, but the one that we're going to be focused on is the player who did drag this part. So we're going to pass in the player, and we can just print something like player.name concatenate with has started dragging like this. And then there's other events like DragDetector.dragContinue connect function, pass in the player like this. And we could just take this print statement and paste it down here, is still dragging like this. And then finally, there's another one called DragDetector.dragEnd connect function, open close parentheses, player, enter. And then we can basically copy this, paste it down here, has ended or has stopped dragging like this. So DragStart, it only fires once the player actually does start dragging this drag detector. DragContinue is going to repeatedly print this statement out for every frame that the drag is being dragged across the screen. And then DragEnd is only going to fire once we let go of the drag. So if we were to test this out in game, then we can hold the drag, and then it's going to print in the output saying Brawl Battle has started dragging. And then once we drag, it's going to continuously print the statement for every time that the frame for this dragging changes. And then once I let go, then it's going to say Brawl Battle has stopped dragging. And there's other ways we can get information about this drag using a property. And this property is called drag frame down here, which basically consists of two values, a positional value and an orientation value. And this tells us what position this drag is currently taking place in. And then once we let go of the drag, that's when it resets back to 0 for both position and orientation. So we can do that down here by detecting it by saying drag detector : get property changed signal open and close parentheses, and then whatever the property is here, which is drag frame. And then we're going to connect this to a function. So connect function, open and close parentheses, enter. And we can basically get any information we want from this drag frame. So we can, let's say, print out the DragDetector.dragFrame.position, just like this. And this is something we can print out. Obviously, there's other things we can print here, like the orientation, or there's even more specific things we can do. So DragFrame.position.magnitude unit. And if we don't want the position, then we can have something different like the look vector and all of these other sorts of vectors here. But let's say we want to locate the position. So I'm going to comment out this DragContinue event here, and now we're going to hit play. So we should be able to see what happens to the position of the drag whenever we're moving alongside the X direction. It's slowly yet surely decreasing the X position of this part right here. And so that is something I want you to take away from this. And as you can see, the limit came down to when it reached -5, and we can't go down any further past this point. And then if we make it go back down this way, then it's going to reset back down to 0. And that is essentially some pretty useful things we can use when it comes to scripting these drag detectors. And I hope you found this part to be helpful. So that is basically the introduction to drag detectors. Now, there are some things I did not get to cover in this episode, like permission policy, which is basically which player can drag this part, or if anybody can drag this part, as a matter of fact. And then there's other ones like whether we can run this locally on the player side so that no other player can see the dragging that's happening. I will let you experiment and try these things out for yourself, but I think for the most part, I was able to at least get you to try these drag detectors out for yourself. And I hope that you found this video to be very, very informative, and I definitely enjoyed making this episode. Now, before you go, I want to give a shout out to my second and third Patreon members, Boopy Your Nose and TragVJF, but he likes to go by T for short, for directly supporting me through my Patreon. And it's honestly it's very heartwarming to see that there are people where I've impacted them so much through my videos that they'd be willing to support me through my Patreon. And that is something I really love to see. And I can't be more grateful that I have people who are like that. But anyways, if you want to do the same thing for me, I will leave a link to my Patreon page in the description where you can get access to all of my scripts and assets that I've created throughout this entire series. And you can also get access to videos early before everyone else, and maybe some additional bonus content that I will occasionally put out on my Patreon as well. So go ahead and check that out. And with that, I will now conclude this episode. I will see you in the next one. Take care.